this is integrated 3, it's problem 5-25, and it says it wants me to graph f of x equals 1/2 x minus 1 cubed, and its inverse on the same set of axes. So I'm going to graph this function on my graph paper, and then I'm going to find its inverse and graph that also on the same set of axes. So I recognize this function because it's one of my parent functions. We learned the parent functions at the beginning of the year, and we all have a paper that's kind of like this. Hopefully we didn't lose it. The parent function for this is my cubic right here. And so I can expect the graph to look kind of like my cubic, but it's been transformed, x minus h plus k. So my locator point on the parent function is at 0, 0. It's at 0, 0. This one's going to get moved to the right by 1, and it's going to have a vertical stretch. Actually, I think it's going to be a compression here. So I have some expectations about how my graph's going to look. I think it's going to kind of go something like this. So I'm going to plug some points in. Usually I do -1, 0, and 1. I might need to do a lot more than that to get this cubic, but I plugged in my -1, and I think I should get -4 out. Let's see. -1 minus 1 makes -2. -2 cubed, that's -2 times -2 times -2. That is -8, and half of -8 is -4. So there's -1. Okay, so there's a point. If I plug in 0, I'll get 0 minus 1 is -1, and -1 cubed is -1, and -1 times 1/2 is -1/2. So let's see, 0, -1/2. Well, that kind of makes sense because I was thinking it was going to go along like that. And then let's plug in 1. So 1 minus 1 makes 0, and 0 cubed is 0, and 0 times 1/2 is 0. So 1 comma 0. Oh, well, I already have that point, don't I? Let's just try 2, just to see what happens. 2 minus 1 is 1, and 1 cubed is 1, times 1/2 is 1/2. Oh, it's got some symmetry to it, doesn't it? Yeah, so that's going to help me. So, well, let's just do maybe one more point. Let's do 3. 3 minus 1 is 2. 2 cubed is 8, and half of 8 is 4. So let's see. So now I kind of have an idea how this thing goes. And I'm not very surprised that it would do something like this. I know it's not a beautiful sketch, but I graphed it by hand, so it's all right. I'm going to, in a different color, maybe this blue color, I'm going to just flip-flop the table. So F inverse of x is going to be this table right here. So I'm basically going to take the x and y coordinates and trade them. You'll see. Right? Because that's what inverses do. They switch the x and y. So this is going to be -4 comma -1. I'll mark it off that I did it. -1/2 and 0. 0 comma 1. I hope I don't make a mistake. 0 comma 1. 1/2 comma 2. 4 comma 3. Oh, yeah. Okay, so I think it's going it's not perfect. It's not perfect, but I tried my best, and I think it's good enough, and that you should see there's a reflection through this line, this diagonal line, y equals x. You should see there's like a little reflection there. And so is that all I had to do? That's all I had to do. So we're done.